Okay, so I'm going to do a couple of extra questions today, just so hopefully if I do them now, it'll help you get your head around them for further ones that might look similar for the papers that come later in the program. Cool, so this one here is a calculus question that's going to involve doing optimization, and we need to set up the equation first of all. So they're asking us to show that the total surface area is given by this formula here. And you know that I'm going to draw stuff because drawing things just helps you to get your handle on things. So you've got a cuboid, and a cuboid is not a cube. It's what you might call a rectangular prism. So all the sides don't have to be equal. So we know that it's got sides x and side 3x, like that. And we need to know what this side here is. We don't know it yet. But they have told us that the volume of the cuboid is 288. So the volume of the cuboid, if I called that side there y or something, we know that y times x times 3x, okay, so 3x squared y, that would equal 288. So then the side that we don't know is the same as 288 over 3x squared, which is the same as 96 all over x squared. Okay, so what we can do over here on my diagram is just take that off and add that there, so 96 over x squared. So that's the first part there, is to use the volume of the cuboid to work out what that other side of my cuboid is. To show the total surface area, if we imagine taking our cuboid here and make it into a net, we've got 6 sides that we need to use, and they're going to be pairs that are equal. So those 2 pairs will be equal, those 2 pairs will be equal, and those 2 sides will be equal. Cool, so all we have to do is use these 3 sides of our cuboid there and find them all in terms of x. So the surface area is going to be 2 lots of x times 3x, which is 3x squared. Also, it's going to be 2 lots of x times 96 over x squared. And it's also going to be 2 lots of 3x times 96 over x squared. And when you go through and simplify all that, you get 6x squared plus 768 over x. Okay, excuse me, and then for part 2, we have to find the stationary value of A and determine its nature. So let me just write out the equation again. So A equals 6x squared plus 768 over x. We know that stationary values is when the gradient is 0. Excuse me. So let's go ahead and differentiate this. What we're going to do to make it easy for ourselves is we're going to make this x to the power of -1 before we differentiate, just so that we can do our whole multiplication thingy with the powers. So we differentiate that, we get 12x, and we get minus 768 to the power of -2, because we're taking away a power. To find the stationary value, we know that that's when dy dx equals 0, or in this case here it's dA dx. So let's set that equal to 0, and I think maybe if you did find this one tricky, it might just be because of that negative power. What I would recommend doing when you're solving equations is to not solve equations with negative powers or with fractional powers, is to put them back how they should look. So if I put that back how it should look, it would be like this. Like that. Which looks a little bit nicer. And what I'm going to do is move that to the right hand side. So I get that. And then I'm going to multiply both sides by x squared. So I get 12x cubed equals 768. 7x cubed equals 768 divided by 12, 64. And so then x equals the third root of 64. Which is 4. Now before I go further and determine what the nature of that station value is, I need to make sure I actually work out what a is. So if we go back here to our original equation, and if I substitute in 4 for x, so a equals 6, 4 squared plus 768 all over 4, I'm going to get an area there of 288. And what I need to do now is determine what the nature of that stationary value is. Is it a minimum? Is it a maximum? And to do that, I'm going to use the second derivative. So if I take this again here, oh, not that one, sorry. If I take the derivative here and do a second derivative of that, so dA squared over dx squared, I'm going to get 12 plus 1,500, what is that? I can't do it in my head, and 36 x to the power of negative 3. Just ran enough space there to put it on the same line. And then what I do is, I'm going to skip down to here, sorry, I'm going to substitute in the value for the stationary point, the x value, which is 4. So if I put that all in there, that gives me a value of 36. And all I need to know is whether it's a positive or negative value. It's a positive value, so therefore that's a minimum value for our stationary value.